In this video, we are going to learn about the hypothesis test involving differences of two proportions given pi1 minus pi2 for large sample, n1 greater than equals to 30 and n2 is greater than equals to 30. So the hypothesis for the differences of two proportions given the null hypothesis is pi1 minus pi2 equals to pi naught, and the alternative of the hypothesis can be pi1 minus pi2 greater than pi naught. So we will reject H naught when the Z test is greater than Z alpha. And for the alternative hypothesis that is less than pi naught, we will reject H naught when Z test less than minus Z alpha. And the last one is for the hypothesis, alternative hypothesis for the difference of two proportions is not equals to pi naught. We will reject H naught when the modulus of Z test is greater than Z alpha over 2. And this is the test statistic which we will use the Z test equals to P1 minus P2, given P is the sample proportion from the first population minus with the sample proportion from the second population minus with pi naught over the square root of PP times with 1 minus PP, given that PP is the pool sample proportion, okay, and times with the square root of 1 over n1 plus 1 over n2. So how do we find the pool sample proportion? Is using this formula, which is the sample proportion from population 1 times with n1 plus p2 over n2 over n1 plus n2. So that's how we find the test statistic. So now let's go through the example 1. Okay, two groups. Okay, here we have two groups from urban and rural are each comprised 100 people who had contact a certain type of disease were taken as samples. So these two groups are comprised of 100 people. So a serum was given to the group from urban area but not to the group from rural area. Otherwise, the two groups were given the same treatment. So here we have two groups, urban and rural, and these 100 people is given as our NU and also NR. And it was found that in the group from urban area and the group from rural area, 75 and 65 people respectively recovered from the disease. So we can find this as our proportion from the sample of urban, given that it is 75 out of 100 recovered from the disease. Meanwhile, for the rural area, is equals to 65 over 100 recovered from the disease. So we want to test the hypothesis that the serum helped to recover the disease using 1% significance level. So alpha is given as 0.01. First, we define our hypothesis given our H naught is pi1 equals to pi2, given this one is for urban and this one for rural, and the alternative would be pi u not equals to pi r. So first of all, let's find the pool sample proportion, where 1 is refers to the urban times with 100 plus with 0.65 times with 100 divided by n1 plus n2 is 200. which is equals to 0.7. So then next is we find the z-test. Here our P1 is 0.75 minus with 0.65, where this our H naught can also be written as pi u minus pi r equals to 0, and for the alternative would be pi u minus pi r not equals to 0. So given that the pi naught value is equals to 0 over the square root of 0.7 times with 1 minus 0.7, which is 0.3, times with 1 over 100 plus 1 over 100, which is equals to 1.543. So this is the value of our z-test. Since the alternative hypothesis is not equal, so we divide alpha into 2. So first we find z alpha over 2, which is equals to z 0.01 over 2 is equals to z 0.005, where z 0.005 is equals to 2.575. And also this one will be negative z 0.005, which is equals to negative 2.575. So here you can see that the z-test 1.543 lies at the acceptance region, which is 1.543. So since z-test equals to 1.543 less than z 0.005, then we can say that we accept H naught. So the conclusion is that the data does not provide sufficient evidence to support the claim that the serum had helped to cure the disease at 1% significance level. So that's all about the hypothesis test involving differences of two proportions.